Assalamu alaikum dear students. Hope things are smooth and streamlined with you and you all have been doing good, and I also expect that you are utilizing this time for very effectively. You are not wasting this time leisurely and use this time to grow and develop yourself. In today's video lecture, you know that we have taken the examination, T1 examination recently of both the classes, and today I decided that there was some questions students faced difficulty, and some I got a queries from students that explain this question or that question. So I decided that I make a video lecture on that, and so that you can have a clear idea about what was the about the question. And I also show you in this video lecture that how to eliminate the options, so it will help you in the future coming examination, any competitive examination which you are going to appear. So hope you will enjoy this video. So first question I want to discuss, which student frequently most of the students have done it wrong. It was the decimal expansion of a rational number is. And let me tell you one thing, that this video lecture is common for both the classes. In the one question was the decimal expansion of rational number is, you know it, we have done it in the rational numbers for both the classes 9th and 10th. Remember this, the decimal expansion of the rational number is either terminating or non-terminating. Remember this, non-terminating, repeating or recurring, we often call it. Either terminating or non-terminating, repeating. What is terminating? For example, if I have a number like this 0.35, this is terminating. So this number here, the after, if you have divide the two quantities, for example 5 by 8, and after complete dividing 5 by 7, suppose, so you will get this 0.35 or something else, we can say not 0.35. This is the terminating, means that remainder is 0, further division is not possible. Hope you will get it. Non-terminating, repeating. Non-terminating, if you get after dividing numerator by denominator, you get that expansion like this 0.542, 3542, 542, 542, 542. So it will go on endlessly. But here if you see the pattern, this 542, it continuously repeats. So we can write it 0.542 bar. This type of decimal expansion is known as non-terminating, repeating, or non-terminating, recurring. So when you see this type of a decimal expansion, answer is, you immediately one thing come into your mind, that this is a rational number. This is also a rational number. So I hope you will get it. The decimal, let's repeat it, the decimal expansion of rational number is either terminating or non-terminating or repeating. So what is the decimal expansion of irrational number? It is non-terminating, non-repeating. For example, if you have a number like this 0.31, 311, 3111, 31111, 31111, and so on and so forth. This type of number where you don't see any pattern, and you see that neither this is terminating nor this is repeating. So this type of numbers, when you see this type of expansion, immediately you should tell that you should say that this number is an irrational number. So I hope you will get this very carefully. And let me tell you one thing, the question was, I will write the question here and show you how to eliminate the options. Question was, the decimal expansion of rational number is, there was options. One option was non-terminating, non-terminating. I will write the option non-terminating. Second option was non-terminating repeating. Third option was non-terminating non-repeating. Fourth option was both A and B. Most of the students have marked this part as their correct answers. So in any competitive examination, I will recommend you that never do the things in rush. The best method is read all the options. You have read it. This thing is in common. This thing comes frequently in your mind. The decimal expansion of rational number is non-terminating. But you go and make the mark this correct answer without reading these options. So important thing in any competitive examination is read all the options, so that there might be the two options which are correct for this question. Say, look, this is non-terminating, this is irrational. Non-terminating repeating, this is also irrational. Non-terminating repeating, this is also irrational. So this option is correct, this option is correct. So answer is D. Most of the students have marked this question as their correct answer. So remember, be careful in future. Best method is read all the options, and you have the knowledge about these, and choose the correct answer after that. So another question was, which is very important, I guess. Let me see. Yes, it was the look here. We have the pair of linear equations: a1x plus b1y plus c1 equals 0, a2x plus b2y plus c2 equals 0. Remember this. So the condition which were asked in this question, that what is the condition for a1 and b1? It is, remember this, a1 square plus b1 square not equal to 0, a2 square plus b2 square not equal to 0. Most of the students have made write that a1 square plus b1 square is not equal to 0, and this option they have made it 0, which was wrong. So remember this, whenever you see this type of questions, that what is the condition for a1 b1, remember it is both the a1 square plus b1 square should not equal to 0, a2 square plus b2 square should not equal to 0. One more question was that the discriminant, remember this question was, most of the students have did it wrong. It was x square plus 4x plus 5. You were asked to find the discriminant of this question. You know it, discriminant is equal to b square minus 4a. See, this is b square, this is 4 square minus 4 into, this is your a, into 1 into 5. So this is 16 minus 20, this is minus 4. So option to this question was 4. Second part was minus 16 by 4. Third part was 36, yes. And fourth part was minus 36. Have a look. So when you do it in a rush, b square minus 4ac, you arrive at the 4. So in a rush, you see that here is a 4, you immediately mark this your correct answer without seeing there was a minus 4. And sometimes some students, one thing comes in mind, that we didn't get any number in a fractional form, so it is in the integer form. So just make this answer, or either answer would be this or this, because we get a discriminant in integer form, not fractional form. But look, this is also in integer form, 4 ones, 4 fours. So answer was this. Most of the students have marked this part as their answers. So hope be careful in future. Another question was, it was a very important question. Alpha beta are the roots of the quadratic equation ax square plus bx plus c equals 0. Alpha, beta are the roots of the, so this is a quadratic equation. So it has two roots, alpha and beta. You are supposed to find alpha square plus beta square. Remember this, alpha square plus beta square. Have a look. A square plus b square, this is equals a plus b whole square minus twice a b. If you evaluate this, you will arrive at this. So we will write it alpha plus beta whole square minus twice alpha beta. So alpha plus beta, this is sum of roots. This is minus b by a square minus 2 into what is alpha? Alpha into beta. It means product of roots. This is c by a. So this is equals b square by a square minus twice ca. Make a square as their LCM. So it becomes b square minus 2ac divided by a square. Most of the students have faced difficulty in doing this question. So I hope you will get these. Another question was, let me see, have a look. Another question was, it was very important question, I guess. Yes, relatively prime numbers. Which numbers are called the relatively prime numbers? Two numbers are said to be the relatively prime. Relatively prime. Relatively prime. Relatively prime numbers. Two numbers are said to be the relatively prime numbers if their common factor is 1. These numbers are also called the co-prime numbers or co-prime numbers. Co-prime numbers. Two numbers are said to be relatively prime numbers, or if their common factor is 1, or we also called these numbers as co-prime numbers. So option were 8, 16, 5, 10, 6, 17 and 2, 8. Most of the students have made this their correct answer, marked this as their correct answer. So you have a look here, common factor is 2 and 1, so this is not relatively prime. Common factor is 5 and 1, this is not common, this is not here, this was a relatively prime. Not prime, this is not as prime which has only two factors. For example, 5, 7, 11, these are called prime numbers. These are called the relatively prime numbers. This is not necessary that these both the numbers should be prime. So one may be composite numbers. So relatively prime numbers 6 and 17. Another question was, it was for both the classes that yes, 2 plus root 2. What is 2 plus root 2? Remember this 2 is a rational number, this 2 is an irrational number. Rational plus irrational, this is always an irrational number. Irrational number, this is always an irrational number. When you see the rational plus irrational, this is always an irrational number. Similarly, for multiplication, for example, 2 into root 2, 2 into root, one rational, another irrational, answer is always irrational. For division, for subtraction, answer is always irrational. Without looking into this question, without dig deep into this question, just when you see one rational, one irrational, frequently one thing must come in your mind, that is this number is irrational. Another question, it was criteria, it was for the 9th class, that which of the following is not the criteria for congruence. So option were AAS, ASA, another was SSS and AAA. Remember this, these all are criteria for congruence. This AAA is not criteria for congruence, but for class 10th students, I want to recall them that here this is the similar, this AAA is a criteria for the similar triangles, not for congruence triangles. So one more question was that we were given a polynomial p of x equals pi x cube. It is meant for both the classes, 9x4 plus 8x square plus 3x. So you were asked how many zeros this polynomial have. Most of the students have marked infinite as their answer. Not. Remember this, if you have attended my lectures, my classes at the beginning in our institute or school, I have already told you the fundamental theorem of algebra, that an equation having degree n has n zeros. So the degree of this polynomial is 4. degree of this polynomial is 4, so it has 4 zeros. Remember this, degree of polynomial is 4, it has 4 zeros. So any number of degree, if the degree is n, it has n zeros. You have to borrow this thing in your mind. Most important question, one of the most important question in this chapter was that root of AB equals root A into root B. Root of AB equals root A into B holds when there were options when both were negative, both were positive, at least one of them were positive. Remember this. This equation holds good. This equation holds only if either both should be positive. Either both should be positive. Both A and B should be positive. Should be positive. Or at least one of them should be positive. Or at least one of them should be positive. One of them should be positive. So this question was marked wrong by all of you. So answer is, so I hope you will remember this thing, that whenever you were asked, you were asked to find what when this equation holds, this holds only either both should be positive or at least one of them should be positive. I will give you example. For example, if you have 2 into 3, this is root 2 into root 3, correct? Both are positive. If you have root 2 into, for example, minus 3, this is root 2 into root minus 3, this is also a correct. But if you have both the negative, so this is minus root 2, this is minus root 3, this is not true. These are called the imaginary imaginary numbers are both. This is not true. You will see it in your later classes. So remember this the answer is that if you see this type of question, answer is that both the numbers should be positive or either one of them should be positive. So this was all about in today's lecture, video lecture. If you still anybody among have one in difficulty in or have any doubt in the questions that were asked in the examination, please let me know, that I will make the video for that questions also. I hope we will enjoy this lecture, and I also recommend you please do subscribe this channel, share this channel, and if you have any suggestion and or any if you have any suggestion, it will be most welcome. Please let me know that. Thank you, class.